My name is Kathryn Grayson Nanz. I am a developer advocate at Progress Software, and I'm a UI designer and a front-end developer who especially loves to work on the front of the front end, which basically means that my dream day would be spending my time writing absolutely nothing but CSS. This, as I have discovered over the years, is an unpopular opinion. CSS gets a bit of a bad rep from back in the day, but a lot of folks are not aware of all the ways that it has developed and improved. The CSS that we can write now is pretty drastically different to the CSS we were writing a decade ago, or even just a few years ago. We are seeing drastic leaps and bounds forward in this field, including tons of new and exciting stuff that we know is going to be coming in the next few years. So this is the perfect time to get caught up if you have maybe not been super tuned in to CSS. It's a really exciting part of tech right now that I think a lot of folks might be overlooking or possibly just not aware of at all. Now, CSS in general is a pretty broad topic, but today we are diving into a specific part that I especially love, which is responsive CSS. And one of the most notable places where we can see evidence of all of these new developments and these big changes in CSS is in the fall of the humble media query. In ye olden days of web development, in the old days of web development, if we wanted to create websites and applications that were responsive, it meant writing a series of different media queries that were all based around specific device breakpoints. So you have breakpoints for all the different models of phones, tablets, for desktop sizes, and then we were reworking our content to try and optimize it for every different size. If you were coding during that time, you might remember getting 2 or 3 very different mock-ups from a design team, and then trying to build 3 very different versions of a website to match those. And yes, before someone comes and says that the truly old days of web dev styling were table-based layouts, I remember those, and they also sucked. Shout out to the email devs who are still very much doing that. However, back in the world of web and application development, we saw CSS frameworks step in to try and ease that device breakpoint pain point. We saw the rise of things like Bootstrap or Skeleton that define different automatically resizing column-based layouts because the task of writing all of those media queries was a lot of work. However, those had their own drawbacks as well. The code that we wrote with those often felt really clunky because that meant that every element required a ton of different class names in order to correctly resize when those media queries were hit. It also was a little restrictive in terms of design. This era of the web is when we really started to hear that like all websites look the same complaint. And a lot of that was happening because it was just so difficult to write responsive code then. We were figuring it out, our tool set was limited, we were doing the best with what we had, but unless you wanted to sit down and personally write 20 or 30 custom media queries and God knows how many correlating classes, you were probably using some kind of a styling library to help ease that pain. And that did lead to some visually repetitive work. Slowly, though, we saw the best practices around writing media queries shift by necessity from device-based breakpoints to content-based breakpoints, as more and more devices were coming out in more shapes and sizes. It became unsustainable to cater to every individual device, and it made more sense to shape our breakpoints around the actual content on the page and when that needed to shift. This meant looking at every design element and deciding when it no longer fit in the screen size allotted for its current configuration, and then changing the layout of that specific element at the screen size when it no longer worked. And this was effective in that it created a really nice user experience, but it also had drawbacks. It was also a lot of work. But perhaps more importantly, it required the developer to make design decisions, because it became their call, ultimately, on when something no longer looked good. This also created code that was difficult to maintain, since it more or less required creating a new media query for every major element on the page. So more media queries, more classes, more names that we had to come up with, which, as everyone knows, hardest thing in computer science. More places for bugs to sneak in, more code for new developers to try and get up to date on when they joined a team. You get the idea. Now, however, with shapes in pretty much every size that you can imagine, from like this little one on my wrist to like ones on the front of your refrigerator, it's time for us to shift our approach once again. The era of breakpoints is over, and the era of fluid design is here. Fluid design means that rather than hitting a point and kind of snapping your content into a new layout, our content should always be continually adjusting based on the amount of space available, using relative CSS properties that will automatically resize our elements. So as a user, it means you're never going to feel that big like snap as you're resizing the screen and everything kind of moves. There's never a situation where all of the elements on the page are shifting at once. This is a more subtle adjustment that's happening constantly, depending on how each individual element is fitting proportionally into the space. It also requires less code, which is nice, and the code can almost always be written directly into the CSS classes that we already have for each element, rather than like separated down to the bottom of the document the way that we had to with media queries. Thankfully, again, the CSS we're writing has come a long way since those early approaches as well, but old habits can be hard to break. A lot of us got really used to just throwing in a media query or 10 or 20 in order to make things responsive, and we never really stopped to reassess that approach or necessarily tried to break that habit. But now we have some really fantastic CSS features like grid and flexbox and calc and clamp and aspect ratio. With all of these at our fingertips, it is time for us to finally ditch those media queries. So today, we are going to start at the top and work our way down from like big picture display formatting all the way to the smallest CSS units. And just to clarify before we begin, everything I'm going to talk about today is fully supported, valid CSS that you can use across all the major browsers, so Firefox, Chrome, Safari, and Edge. That means that while there is some cool stuff that we know is coming or is like partially here, I'm not going to include it in this talk until it is fully standardized and supported. I bring this up because sometimes I have people ask me about things like the has pseudo selector that is currently supported in some browsers, but not all of them, or like things that only work in Chrome Canary. But for this, I am choosing to focus on code that you could implement right now, today. And as for your old style sheets, don't worry. We can refactor them. We have the technology. Let's start with two of the most popular responsive display options, grid and flex. These have actually been around for a minute, with grid hitting full browser support in 2017 and flexbox in 2013, but a lot of folks still don't fully understand the difference between them or know when they should use one or the other, or possibly even both. In fact, many people kind of assume a false equivalency between them that can create this kind of either-or approach, like you have to choose between two options, when in reality, they not only have very different use cases, but also can and should be used together to complement each other. We're not going to be able to cover every single aspect of these tools, especially grid, which is just immensely powerful now that subgrid has full support. But for our purposes today, I really want to focus on how these tools work at a high level, what they do best, how you can use them to handle the responsive elements on the page without needing a media query. So grid is primarily focused on creating a grid, something with multiple rows and columns that you can populate with elements. You do this by creating a container grid element, which you then fill with child elements. And there's a huge number of customizations you can make to the grid rows, columns, and cells that will allow you to create grids and subgrids as simple or complex as you could possibly imagine. Grids, however, have been a staple in the world of design since well before CSS was even an idea. There are many different types of standard grids in the design world, but the one that I want to focus on is the modular grid, which is the basis of the CSS grid approach. I've noticed that a lot of folks struggle with CSS grid, and I think that that's because they don't have that functional understanding of an actual grid to kind of back it up. So let's take a second to break down the grid and relate it to the CSS grid properties. A grid structure contains two primary areas, the grid itself and the margin around it. This, of course, maps perfectly to our CSS approach of the grid element and the margin property that we apply to it. Within the grid, we have columns and rows, which we define using grid template columns and grid template row properties in CSS. Those divide the space inside the grid into modules, or equally spaced sections. In design, when an element spans multiple modules in a grid, it's referred to as a spatial zone. In CSS grid terminology, the closest correlation that we have is a grid item. But because we have no real term for the modules in CSS grid, I see a lot of folks mistakenly equate grid items with modules, which can really throw off your work, since modules are always going to be those smaller pieces in a module grid, where spatial zones or grid items can be any size and span these dimensions because they take up multiple modules. Having an understanding of modules also really helps when it comes to understanding the line-based placement approach to positioning items in your grid, which we're going to touch on in just a minute. So in CSS grid, you name your spatial zones using the grid area property, and this defines a specific spatial zone that a grid item will fill entirely, and allows you to also designate it specifically with a name, like header or footer, which makes your grid easier to understand, and also makes it a little bit more flexible, reusable, if you're going to be implementing that in like several places as a template across your code base. Next, let's take a look at the space in between your modules. You might be tempted to think about this space as a margin, because that's kind of how we've learned to conceptualize this with the box model, but these are actually gutters or gaps in the grid, and we define them with row gap and column gap. You might occasionally see these written as grid row gap or grid column gap, but you don't actually need to do that anymore. Those prefixes were dropped a while, so you don't need to include them. Your column and row gap values don't have to be the same either. You could have a wider like row gap than a column gap. That's totally up to design preference. The next piece of confusion that I see most often in regards to using the grid has to do with the ways that you can define a grid. And there are kind of two main ways that you can go about this. You can either spell out the specific number of rows, columns, the exact specifications that you want, and then place items in that structure. Or you can create a grid, create some grid items, and let CSS grid kind of fill in all that stuff in between. Both are useful approaches, kind of depending on time and place. A grid that you don't get as specific with is going to be a little bit more flexible, but because you're relying on this auto flow placement, you will have less control over where specific elements are at any given screen size. So that can be a good approach for something like a photo gallery, where it doesn't really matter like which image is on which line based on screen width. A more explicitly defined grid is going to have some less like natural adaptability, because it's not going to shift or wrap unless you tell it to. So this is better for places where you're using the grid to define your page structure. You don't want your sidebar to wrap and like no longer be a sidebar anymore. This is also a really good place where you can use Flexbox in combination with grid. So even if your large-scale grid is not going to like shift or wrap on its own, you can have the contents of each individual grid item do so by wrapping those child elements in a Flex container. That will allow you to keep this responsive nature, but also do so within the confines of like a higher, more stable structure. So to look at a quick example, you can get pretty specific with your grid item placement, and it looks something like the code here. So here we're placing an item on the second column, moving from left to right, telling it to span the width of 4 columns. We're also saying it should be on the third row, moving top to bottom, and span the width of 2 rows. Sometimes you will see this referred to as line-based placement. On the other hand, if you declare a grid and you're not specifying this kind of exacting placement, then the grid will handle it itself using their auto placement algorithm. While you'll still be able to kind of shed a few media queries with grid no matter how you use it, the more flexible approach is especially effective for replacing some of the ways we used to write media queries to reflow elements on the page. And that looks something like this. So in this situation, the grid is going to turn your content into columns which naturally fit the space that you have, with each column having a minimum width of at least 300 pixels and a maximum width of no more than 1 FR, 1 fraction. This allows us to set some general kinds of guidelines without needing to use those breakpoints in order to do so. That 1 FR, if you haven't seen it before, is a newer CSS unit that stands for fraction. That tells the browser to divide the space evenly and give each column a fraction of the space. So in this case, it's going to create 3 equal columns that each take up 1/3 of the available space, but will never get smaller than 300 pixels. And if we were to add another div or take one away inside that wrapper there, the grid would handle that automatically and adjust the display. So if the screen is too small to fit all of the columns side by side at the same time, it will automatically wrap remaining columns down to the next row. You can add or remove columns. It'll adjust. This is, of course, barely scratching the surface of everything that Grid can do. And if you're looking to create more complex layouts with Grid, these are a few of my absolute favorite resources. A Complete Guide to Grid offers a fantastic breakdown of all the ways you can customize your grid, really diving into like creating columns of varying widths, or setting template areas, or setting the gaps between your grid cells, all of that. Whereas Grid by Example is possibly one of my all-time favorite pieces of documentation, which I realize is one of the most boring things I've ever said in my life. But I swear this is really amazing. This is by far the best place to start when you are looking for a jumping off point on creating a new grid structure. Rachel Andrew has put together a series of just fantastic examples for a wide variety of really different popular grid layouts and configurations. So anytime I'm creating a grid that's going to be more than like a standard, like 5 by 5 kind of box layout, I will start with this resource and use those code samples as a jumping off point to configure for my own purposes. Flexbox takes a similar but not quite the same approach in helping you lay out your elements on the page and adjust them automatically. But rather than creating a full grid with multiple rows and columns, Flexbox is about the positioning of child elements relative to each other within a parent element. So basically, if you need to work in 2 directions at once, you're talking rows and columns, that's when you're going to want to reach for Grid. If you're thinking about one direction, so either a row or a column, that's when you want Flexbox. Flexbox is also especially good for positioning elements within a parent element, including the much maligned vertical centering, which is no longer a struggle in CSS thanks to this. In fact, using Flexbox, you can vertically and horizontally center elements in a div with just 3 lines of code, so you are no longer allowed to make jokes about how centering is hard in CSS. Branching off of this, as we mentioned before, you might want to consider combining this kind of technique with Flexbox inside your grid so that you can easily position elements within a grid item. These 2 different technologies really work and play well together, so do not be afraid to mix and match, and don't ever feel like you need to choose between them. For now, though, let's leave my rant on positioning for another time and bring this back to the topic at hand, which is how Flexbox handles responsiveness for you. The main point of interest here is the Flex Wrap property. Flex will start by attempting to fit everything that you've written into one row or column, but if that isn't going to work, you can tell Flex to allow wrapping by setting Flex Wrap to wrap. If Flex Wrap has not been specified, or if you've set it to no wrap, then Flex will try to squish the elements to keep them all on the same line if you have not specified a minimum width for those child elements, or it will allow them to overflow out of the container if you have set a minimum width. Basically, with both Grid and Flex, you just kind of have to decide whether you want your content to squish or wrap and how, and then set the properties accordingly. Both are really great tools to have in your toolbox for creating responsive UIs without media queries. If you are looking for some resources to master Flexbox, these are a few of my favorites. Flexbox Froggy is a surprisingly fun and addictive little game to help you master what all the different properties of Flex do by using Flexbox to correctly position colored frogs on their matching responsive lily pads. You will lose hours of your life to this game, so beware before you click. But I can pretty much write all of the Flex styles and syntax from memory now, so I guess I got to give some credit to Flexbox Froggy. If you have not, however, logged as many hours as I have on that silly little game and don't have all of the syntax memorized, then I recommend Flex, which is a simple visual cheat sheet for you to kind of reference as you work. Once we've got our general layout in place, it's time to set some specific properties on our elements. And good news, we do not need media queries here either. Container queries have been a long time coming, and folks have been very excited about them. And great news, they are now supported in all major browsers, like as of very recently, within the last couple of months. While some browsers had implemented support for this feature at the end of last year, Firefox was the one dragging its feet, and they have added support as of this February, which means I can now officially talk about it in this talk. Container queries work very much like media queries in terms of how the syntax is structured. However, instead of checking the dimensions of the browser window, they're going to check the dimensions of a specific element on the page. This can be done in two ways, either by defining specific elements as named containers and then writing container queries for that element, or by defining unnamed containers, in which case just the nearest ancestor container will be used. So here's how that looks in practice. In both situations, you need to designate which element you want to use as the container. So here we are setting that section with the about class as our container. And then the styles inside the container query will be applied when the container matches those conditions, just like a media query. We set a container by specifying a container type on the element. And a container type can be set to one of two options. And I hear you already grumbling. There are 3 options on the screen. There are. I swear I can count. But only 2 of these are currently functional and usable, and that is size and inline size. So size is going to check the inline and block dimensions of the container, where inline size will only, of course, check the inline dimensions. The third option, compellingly named normal, is just laying the groundwork for the support of style queries in CSS. That is a new type of query, which we don't have yet, that will check elements based on the applied styles and not the dimensions. It's going to be very cool, but they are not yet supported, and honestly, we're still probably a ways off on that, so don't worry about it too much. Named container queries are great for when we have lots of container queries applied in a single page, so naming can help keep our code a little bit more organized and readable. So to add a name to a container, we define it with container name alongside the container type. And in fact, if you want to be super efficient, you can do both at the same time with this shorthand syntax, which you use by separating the name and the type with a slash. Then, to call that named container, you just add the name between the @container and the conditions in the query itself. Along with this technique, we got some cool new CSS units to be used with it. So there are 6 new CSS units that can be used alongside container queries, all of which define sizes relative to the dimensions of the container. So the example here kind of shows a way to build a typography system using clamp to set minimum and maximum font values, with that default value in the middle set to always be adjusting in relation to the container size. And if you're not familiar with clamp yet, consider this a sneak peek. We're going to talk about it in a little bit. Did you know that there is a CSS property specifically designed to handle aspect ratios? This is especially handy if you're dealing with videos or like those big hero images that are really popular as like the landing page on a website. All situations in which keeping the correct dimensions is really important. There is a fantastic deep dive on this on CSS Tricks, which I've included a link to here. But in general, this is a property that's pretty darn simple, because all you really need is this one line. If you set a specific width or height value along with the aspect ratio, it will use that as a basis and automatically generate a matching height or width to match, or vice versa. However, you do have to be careful, because if you declare both a width and a height, it is going to honor those over the aspect ratio. Although min and max height and width properties can be replaced in most use cases now with the clamp function, which again, I promise we are looking at next, these are still valid CSS and really good to have in your pocket. They're easy to use and just nice, because they kind of say exactly what they do on the tin, right? And there's something about just being able to read your code in a human readable language that makes a lot of sense. So in this example, we have an image that we are telling, first and foremost, take up as much space as you have available, up to the max width. So we're defaulting to the largest size possible. We're going to give it some guide rails, though. We don't actually want it to take up more than half of the container, so it doesn't take over the page. But we also want to make sure it's larger than a postage stamp. So we don't want it smaller than 200 pixels. In this case, we set an absolute value only on the small end, because we know exactly how small that image can get before it becomes unrecognizable. And now, no matter how the browser is resized, we know our image will always be as big as it can be without being either ludicrously giant or unreadably small. The math functions are a somewhat newer addition to CSS and incredibly powerful. They fill a void that developers have been complaining about for ages, which is the ability to compute values within the style sheets themselves and set ranges for properties. So the sooner you can master these and put them to use in your code, the more you will benefit and the more media queries you will be able to delete. Clamp, as promised, allows us to set a base value for a property along with upper and lower caps to contain it as it adjusts. It allows us to set those same kinds of responsive limits that we did in media queries without needing specific breakpoints in order to do so. So here's how it works. This is an updated version of our last example, the image with the min and max widths. Only here, we are doing it all in one line by using clamp. The format is to set your minimum value, your base value, and then your maximum value. So you can kind of imagine it like a continuum, right? You set your default here in the middle, and then an upper cap and a lower cap. So we're telling the image, take up 100% of the available space whenever you can, but never exceed the maximum of half the container size or get smaller than the minimum. If you have ever looked at CSS and wished that it had more math, then first off, I am not sure that we can be friends. But second off, calc is for you. Calc allows you to do arithmetic with CSS units right there in the style sheet. This is especially great for when you need to base something off of a unit that is not absolute, which, as you can imagine, is ideal for creating fluidly responsive layouts. You can also use CSS variables in these computations, which allows us a lot of extra flexibility. So here's a simple example. Let's say we want to create columns that are evenly divided based on the current width of the browser. Setting 1/3 widths has historically been kind of a pain in the ass using percentage units, because you end up with the whole 0.333 repeating situation. And previously, our best bet was to just kind of not pay attention to that and say, like, you know what, close enough, and ignore the fact that it was not actually exact. But now we get to say, you know what, CSS, you handle that, and know that we are going to get absolute mathematic perfection. So here we take the full window width with VW, which we will talk about in a minute if you're not familiar with it, divide it by 3, and set that as the width for the child element. If you are a fan of having your style sheets handle as many decisions for you as possible, then please allow me to introduce you to min and max. They work very similarly to clamp, but rather than allowing a range that moves in both directions, these just kind of move in one. So that allows us to set the smallest or the largest value, depending, again, on what we set and how the math works out. This is also a useful tool for handling those non-fixed values, which, again, something you do a lot. So in this case, we're setting the width for 2 different images, one that we want to keep small, one that we'd like to be larger. Min is going to evaluate whether 200 pixels is greater or lesser than 30% of the current container and choose whichever value is the smallest, whereas max is going to make that same comparison between the 50 VH and the 800 pixels, but it will automatically go with the larger. Now, it's all well and good to think about things from a bird's eye view, the way we need to when we are like laying out the elements on our page. But we can't forget about the little guys, the CSS units that are making all of this happen, specifying the sizes for all of our various properties. When we set everything in hard units like pixels, we are setting ourselves up for a bad time when creating responsive layouts. Absolute values and responsiveness very rarely mix. And in fact, if you find yourself setting an absolute value, you should take that as like a little bit of a yellow flag. It's not necessarily a bad thing, but you should look into it and try to think critically about why you feel like it needs to be set absolutely. Every now and again, it is necessary, but those times, as a kind of rule of thumb, should be few and far between, because it really makes our own lives a lot harder. When we set these absolute values, it means we have to go in and adjust them manually every time we need to like shift around the layout. So if we ever want to make a change in the future, we have to go back, find all the values that we like hard-coded in there, and then update them. However, when we make an attempt to work in responsive units, we can let them do the work for us. So if we need to make a change to them later, we can change just one or two base values that the rest have kind of been keyed around relatively. And as an incredibly lazy developer personally, that is my preference. Two of my favorite and most used responsive units are VH and VW, which are viewport width and viewport height. Although there is no percentage sign included in the unit here, VH and VW are really a type of percentage-based measurement. Like 1 VW is 1% of the viewport width. Gone are the days when viewport measurements had to be obtained via like window.innerWidth and window.innerLength. Again, dark times. Because before we were stuck getting those values in our JavaScript and then trying to find a way to tie that into our styles, which of course we're living in another file, so you end up writing your CSS in your JS, which becomes one more thing to keep track of and just feels gross. Thankfully, we can now keep track of these values automatically in our style sheets and skip all of that mess. VH and VW will also automatically update as a user changes the window size, so there's no hoops to jump through there either. VH is especially useful for those times when you want to center something vertically on the page, which again, historically difficult, or when you want to stick something to the viewport like a sticky header or footer. So to create a container element that will always be the exact height and width of your user's current browser, all you need is height 100 VH, width 100 VW. Vmin and Vmax are interesting little units that are often overlooked and maybe something you didn't know of. They're kind of like a child of min and max functions and VH-VW units. They will take the VH and VW measurements for the viewport and then return whichever one is smaller or larger, depending on whether you're using Vmin or Vmax. So, for example, if you're writing code, you set something to be 100 Vmin, so 100% of the minimum, you're going to get something like 400 pixels on a phone, because they're taller than they are wide, something like 1,600 pixels on a laptop, depending. And this might seem like something of an edge case, but these are actually really great tools for replacing media queries, and specifically the orientation media queries that would adjust our layout for portrait and landscape. Because VH and VW will automatically update when the screen size is changed, so if you rotate a device and it changes, it will update these values, and everything you can key around it will update as well. So in this example, I've set a header that is keyed around the vmin, so it will scale accordingly based on what the visual minimum is. The addition of these viewport units was pretty revolutionary and pretty well received. They are super handy, but developers found one small bump in the road, which was the browser UI itself. So for example, when you do something like pull up the keyboard on your mobile phone, that changes the VH, the visual height. Sometimes the visual width was thrown off by like a scroll bar on the side, or browsers that have a sidebar instead of like a top tab bar. Sometimes on a phone, the browser bar will like go away as you scroll, you know, when you load a page and scroll down and the Chrome kind of disappears. And that changes your visual height as well. This led to some requests for adjustment, and we got that in the form of 12 new CSS units related to the viewport. No, I'm not kidding. Basically, you can group these into 3 main categories, which is large, small, and dynamic. The large viewport units apply to the situation in which the browser or operating system UI is not visible on the page. So for example, you've loaded a page on your phone and you've scrolled down. So all of that like UI with the forward and back buttons and the address bar and the refresh button, you can't see them. LVH, LVW, LVmin, LVmax are all sized assuming the largest possible viewport situation. The small viewport units are the opposite. So that's the size of your visible page when all of that weird browser Chrome is visible. So SVH, SVW, SVmin, SVmax will offer you the options of catering to your smallest potential viewport. The dynamic viewport options are where the real magic happens, though. It kind of automatically adjusts in response to those UI elements being visible or not. So it's a great middle ground between the large and small units, kind of like a Goldilocks situation. So by setting a DVH of 100% on our body, we're going to create styles that will automatically adjust themselves to fit the available viewport, which might change, again, as you scroll or as different parts of the browser UI are visible or not visible on the page. which is pretty darn cool. If you're still defining font sizes in pixels, then please let me tell you about the beauty of rem and em. The name em actually comes from old typographic standards of measurement, which are based around the width of the literal letter M in the font, which is also where the words m dash and n dash come from. Those are dashes equal to the width of the m or n characters in the font. There's your little typography trivia for today. And while em units are no longer bound to this kind of exact measurement, they're a great way of defining your font sizes relative to the font size of the parent element. So you could do something, sorry, I was making sure my slide was on the right thing. You could do something like font size 2.5 em, and that's going to set your headers there to 2.5 times the size of the current body font in the parent element. Rem, on the other hand, will allow you to declare your font size relative to the root font size of the entire page or application, depending on your global styles. Both rem and em work in the same way, in that they're responsively keyed around one base element that they're working relative to. The difference is what they're using as that base size, what they're scaling based upon. So in general, I lean more towards rem over em because I like the consistency that creates. But one of the most common questions I get is, when would I use em? My recommendation is if you're looking to create a specific design in one section of a page that differs from the overall style, so you have a call-out box or a sidebar or something that you want a little bit separate from the styling of the rest of the page, em is going to want to be what you reach for there, because then you can set relative styles that are kind of contained to that one visual element. And if you are looking for a very cool trick, you can combine VW with rem and clamp to create a kind of fluid typography system for your entire application with just this one line of code. So here we're setting our base font size to 2.5 VW, remembering that 1 VW is equal to 1% of the viewport width. And then using clamp, we're setting those min and max values on either side to ensure we don't end up in a situation where the text either gets unreadably small or it just keeps getting bigger forever. Then if we're using relative units for the rest of our typography system, our headers, our block quotes, gosh, suddenly blanked on typography units, we can base them around this fluid value and they will scale and be responsive as well. So set all of the fonts for your thing in one line, key everything around that, can't beat it. Now we have a couple of weird ones. I'll be the first to tell you, these guys are edge cases. You are probably not going to use them very often, but they are valid and supported relative CSS units, so we're going to talk about them. At the very least, now you can impress your team with your knowledge of CSS minutia. I'm talking about CH and EX, which are both measurements that are based on the size of an individual character. These work in the same way as rem and em, kind of mathematically, in that they're setting their sizes relatively to a font in use on the page. EX, or X, is a unit that is equal to the X height of the first available font, meaning the first one listed in your font stack as defined by your font families or the default font on your page. In typography, the X height is the median height of the font, which is always going to be the same height as a lowercase v, w, or x. So when we're using the X unit, we are defining something relative to the height of the lowercase x in the currently used font. Is there a practical use for this? I have to admit, I have only found one. That is the adjustment of superscript and subscript elements. Both sub and sup are notorious for janking up your line height. So if you're using them, and you should, for accessibility purposes, then you will almost certainly have to go in and kind of manually reset the line height. If you reset the position of sub or sup so they don't mess up your line height. X is weirdly perfect for this because you do want a measurement that is relative to the height of the font we're using. So in this example, we are resetting the positioning of the superscript element and setting the bottom for that based on the X height. CH is similar, but it measures character width. And you're over there like, you just said that rem and em units did that. What is the difference? And the answer is almost nothing. The small difference comes from the fact that CH is calculated specifically based on the width of the 0 character. So what the heck do you use that for? I will be the first to admit you are probably not going to pull this one out in your day-to-day, but there are a couple use cases where it can be handy. Some folks argue it can be a good way to set the width for text blocks or text inputs, because we do have data that tells us the human eye can most easily read text that is between 60 to 100 characters in length, and that is including spaces. So shorter than that, there's too many distracting line breaks. We kind of have a hard time following it. Longer than that, and we start to lose our place as our eyes wrap around and have to find the beginning of the next line. So you could make a strong argument for using the CH value, perhaps on either side of a clamp function, to ensure that as your page is resizing, your text blocks are always staying in those most ideal readable widths. Personally, the best case I have found for CH has to do with numeric displays. Because a 0 is usually the widest number in a font, if you're using CH to define like inputs or whatever widths for your layouts, that will ensure that you are unlikely to end up with an overflow situation. So like assuming even someone inputs only the widest numbers possible, you still have plenty of room. Last, but certainly not least, is the humble percentage unit. If you're going to be setting widths by hand for any reason, as opposed to using something like the fraction that's going to automatically define, you are almost certainly going to want to reach for percentages instead of an absolute value. You probably don't need an example on this. I am almost certain you have used it somewhere before, but I am a perfectionist, and I could not leave one slide without an example. That's annoying. So here we have an element that we are setting to be 1/4 the width of its parent. As the parent width changes, this element will automatically adjust as well. Yes, it is simple. It is also absolutely foundational to building responsive UIs. Since we are only talking about responsive design, it is pretty safe to say that with all of these techniques, you can say goodbye to most of your old media queries. However, there are a few situations that are not related to responsiveness where media queries are still our best option. So before we entirely ditch our old friend at media, let's talk about a few places where that is still our best bet. When it comes to ensuring that your app or site is accessible, media queries still play a really important role when it comes to these preferred media features. There are 3 that you should know about. Prefers reduced motion, which we can use to offer removed or reduced motion graphics on the page. That's going to be really appreciated by your users with like nausea or vertigo or epilepsy. Prefers color scheme is going to automatically adjust the color scheme of your website to match your users' operating system level settings for color theme preference. This is really wonderful for users with like low vision, light sensitivity, migraines, etc. And finally, prefers contrast. Will detect whether the user has set a preference for high or low contrast at their system level, and you can set styles that will cater to that specifically, which again, great for users with specific vision needs or pain and sensitivity around light. There are still a few other preferred features in the like experimental coming soon phase. Prefers reduced transparency, which will allow us to offer alternate styles for users that don't want semi-transparent elements, and prefers reduced data, which will allow us to offer like a stripped down version of our websites or applications for users that don't have a dependable internet connection or maybe just don't want to burn through a ton of data. With these user preference media features, we can adjust our content based on the user's system level settings in order to adjust our layouts to be more accessible and more user-friendly. And these are especially important because it doesn't require the user to load an inaccessible page in order to then go in and change their settings. So for example, if we have a user who has light sensitivity and they know that that's going to trigger a migraine, they've already enabled dark mode in their system level settings. We're using prefers color scheme. That user does not then have to load our application in a light mode, find their way to our settings, change the theme in our application. We can do that automatically for them with prefers color scheme. So to users, it's going to feel really intuitive. It's going to feel automatic. It's a small but really wonderful and thoughtful thing that we can do to improve the UX for our applications. If we need to completely change how an element on the page looks or works, or just remove it entirely, we still have no better tool than media queries and basically breakpoint-based changes. So a common example for this is the switch from like a list-based navigation menu to like a hamburger menu or kebab-style icon on a small screen. Because we need to hide and show various elements as part of this switch, like not showing the hamburger icon when the screen is larger, we still do need to handle media queries to make that display none swap. Finally, if you have never had to worry about styling something on your website or in your application for print, let me be the first to say congratulations. I, for one, am deeply jealous because it's a really challenging task to take something that was created for responsive screen-based viewing and then try to make that work on an 8.5 and 11 piece of paper. But when it is a task that we have to handle, media queries still have our back. By specifying print, we can then write a whole new set of styles that will only be applied to our layout if the user is printing a page. This is not exactly cutting-edge, exciting new technology. But if you are working on an application that provides information that users might need when they're offline, when they don't have access to their device, this is something that we can do for them that shows a lot of consideration and empathy. So something like removing the header or the navigation bar, things that click, things that interact, videos that aren't going to play. Putting a display none on those behind a @print media query is just a really kind and thoughtful thing we can do. It shows that we've thought about how they're actually going to use the things that we're building. If you are still relying primarily on media queries to ensure that your site is fully responsive, it might be time to take another look at everything CSS has to offer now and see if you can swap some of those old-fashioned breakpoints out for some of these new fluid approaches to styling. Working to create a fully fluid layout means less drastic changes for your user as they're moving between like mobile and desktop or as they're resizing a browser window, but it also means less maintenance work for you. No more updating every breakpoint whenever there's a change to the design. No more dealing with pieces of code that are split between the top and the bottom of a style sheet. It's just really nice. Leverage these adaptive approaches to styling and get ready to sit back and go with the flow. Here's to building more great stuff for our users and making our own lives easier along the way. Thank you. I think we've got a few extra minutes, so I'm happy to take questions if folks have any. Although I will tell you right now, I can't see you with the lights. So you might have to just holler. I feel like, yes? Yeah, so the question was, how do you deal with long names that don't have a break in it? Yeah, you would probably try to find, there's definitely a way to do that. Flex, I don't think will do that automatically, which is what you were originally asking, if the like flex wrap versus no wrap. And that's just talking about like general elements in a page. So presumably that text would be wrapped in like a paragraph element or something, and you'd have to apply a style directly to that. And the flex set to the container would not do that. Yeah, I think you'd have to look at like character breaking kind of stuff there. Sorry. If there's anyone else, you might just need to come down here. But otherwise, thank you all for your time.